and it is life-changing. It is the future. Often we don't notice it's even there, but it's all around us. It's in our environment, it's in our water, it's in our homes, our streets, and our food. It is at the center of new technology, new forms of energy, new ways to fight disease, and new ways to solve the problems we all face together. It is every day, and it is life-changing. It is the future.
Hi, children. Good evening. Good evening, everyone. I hope you can hear me. Good evening, everyone. How are the things? So, shall we start? Am I audible enough? Yeah. Right. Okay. Good. 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 Right. Then, yeah. Okay. Fine. Right. Thank you. Right. Okay. So let us look at this tutorial number 6. Tutorial 6. And there you have, you start with the chemical calculations that we want, right? Okay. Yeah. Thank you. Right, Harry. Okay. Let's begin. Tutorial number 6. Now, I think I hope you have marked everything that we have done. First page 1, 2, 3, 4 we have discussed. 5, 6, 7 also we have discussed. 8 we have worked on. Now we have question number 9. As far as I have marked, that is what I have. Tell me if I am wrong. Question number 9. Right. Okay. So let us read the question. Let me first get some pages. Right. Okay. Right. Let's look at that. A solution of potassium dichromate is standardized by titrating with sodium ethane dioate. Sodium ethanoate or sodium ethane dioate is sodium oxalate, Na2C2O4. Right? Sodium oxalate is your compound. Titration with dichromate, acidic potassium dichromate, you titrate this with sodium oxalate, Cr2O7. If 47 milliliters of the dichromate solution was needed, so dichromate solution you need 47 milliliters to oxidize 25 milliliters of 0.925, 0.0925 molar solution to oxidize 25 milliliters here. So what do they ask? What is the concentration of the potassium dichromate solution? So in order to work that out, let us look at the dichromate, potassium dichromate and potassium oxalate oxidation. We look at only the important ions. Forget about the spectate ions, right? So you have oxalate C2O4 2 minus and then Cr2O7 2 minus. Dichromate turns into what? What is it turning to? What is it turning to? Hmm? What is it turning to? Dichromate turns into? Uh, Dichromate turns into what? Cr plus 3. Yes. Cr plus 3. Why everyone is saying sending private messages? Can you send it to the main chat so that I can see? Private messages and then very difficult to go through that, right? Main chat, right? Okay, right. Okay, so dichromate, oxalate. What is going on? Yeah. Okay, main chat is disabled. Really? Why is that? But now it is okay. Check. Oh, really? Oh. Now how about, now okay, right. Okay, fine. Sorry about that. Maybe something wrong. All right, thank you. Right, okay. So, okay, right, fine. So, oxalate turns into CO2. Chromate, dichromate turns into Cr plus 3. Other main ions, spectate ions, are the ones that won't react. They are the ones that will just watch the entire process and they wait. There is no change in the oxidation number. So here it is plus 3, here it is plus 4, 1 electron, 2 atoms, that means 2 electrons. Here 2 electrons. Dichromate is plus 6 and this is plus 3. You have 3 electrons, there are 2 atoms, so therefore 6 electrons. Right? 6 electrons, this multiplied by 3. So you multiply this by 3 and then 3 times 2, 6 CO2. 2 chromium, right? Let us check whether we can balance the entire charges here. This one is plus 6. This one is 3 times 2, 6, 6, 2, 8, minus 8. 8 plus 6 is how many oxygens? How many hydrogens? 14 hydrogens. 14 minus 8 is 6. 14 H plus, that means 7 water molecules. So this is your reaction, 7 water molecules. That is your reaction. Once you write that reaction, I hope you are clear with the balance equation. But once you write that reaction, once you write the reaction, you write the stoichiometry and substitution, right? So number of moles of dichromate, Cr2O72 minus, divide by number of moles of oxalate, C2O42 minus. What is that? Or dichromate is 1 and oxalate is 3. C2O4 is 3. So what is the concentration? It says you are using 47 milliliters. Concentration times 47 milliliters. Divide by, this one is 0.0925, 0.0925 moles per cubic decimeter, and then you're using 25 milliliters. Once you use that, you get the stoichiometry 1:3. So milliliters and milliliters cancels out. Our concentration is equal to 0.0925 multiplied by 25 divide by 47 times 3 moles per cubic decimeter. Harida. 0.0925 times 25 divided by 47 times 3 is equal to 0.0164. Is that the answer? Yes, 0.0164. 0.0164 moles per cubic decimeter. Is it clear, Buddha? Everybody understood that? Question number 9 is also done. Everybody okay with that? මේකට දාන්න පුතා මේ don't send private messages මේ දාන්න මේකට main chat එකට දාන්න. Now it is okay and then people can send this. නේද? Right. හරිද? Because otherwise it will be difficult for me to go through මේක මාරු වෙනකොට අපිට මේ we can't use the in the optimum manner. හරි. Okay, did you all understand that? Yeah? Is it clear? Right, okay. Everybody, children, main chat එකට දාන්න. Okay. එහෙම එක්කුත් තියනවාද? Right, okay. All right, okay. So let us see. හරිද? Question number 9 is done. Question number 9 is done. හරිද? 9 is done. I think question number 10 we did it, right? Question number 10 we did. 11 we did. 12 we did. If I haven't done it and I have marked it, please tell me, right? Question number 13, I haven't done the theory. So wait till I finish the theory next week. So question number 13, we haven't done. Question number 14, I think we should be able to do it. Let us look at question number 14. Hurry. Read the question, children. Read the question and see whether we can do this. Question number 14. A piece of steel of mass 0.2 reacted with dilute sulfuric. The resulting solution requires potassium permanganate acidic solution in titration. Calculate the percentage of iron in the steel. Right? What would you get? Now let us say if you have iron Fe. Now piece of steel, that is the main ingredient that is present. But there are some other compounds as well. Various types of other materials also there. Various types of other materials are there. And then if you add sulfuric to this, what would you get? What do you get? I told you whenever it reacts with sulfuric, it goes to the next available oxidation state. Next available oxidation state is next available oxidation state means lower oxidation state Fe plus 2. Ferrous sulfate FeSO4 and hydrogen gas is evolved out. Did you understand that? Ferrous sulfate, hydrogen gas is evolved out. Hydrogen gas evolves out. Now what you do is you take that ferrous sulfate and we titrate it. So what will happen? You have Fe plus 2. Fe plus 2 turns into what? With MnO4 minus, what is it turning to? Fe plus 2 turns into? Fe plus 2 turns into what? What is it turning to? Fe plus 2 turns to Fe plus 3. And MnO4 minus turns into Mn plus 2. Right. Balance the reaction, will you? Right. This is plus 7 to plus 2, 5 electrons. This is 1 electron. That means you multiply this by 5. 4 oxygen means 4 water. 4 times 2, 8H plus. This is the reaction. Now you have the balance equation. Once you have the balance equation, let us get the stoichiometry going. So number of moles of Fe plus 2 to number of moles of permanganate. What is that? Fe plus 2 is 5. Permanganate is 1. So what is the number of moles of Fe plus 2? Number of moles of Fe plus 2 is equal to 5 times the permanganate. What is the permanganate amount? It says 0.02 34 milliliters. 0.02 times 34 milliliters, 10 to the power minus 3 moles. Can you tell me what is the number of moles that you get? 5 times 0.02 times 34 10 to the power minus 3 is equal to 3.4 10 to the power minus 3. So this is the number of moles of Fe plus 2 that is present. Number of moles of Fe plus 2 that is present is this amount. Yeah. Everybody understood that? So if you look at the Fe plus 2, whatever the amount that is there, you get from Fe. Fe plus 2, you get it from Fe. 1 is to 1 ratio. If you have 1 mole here, you get 1 mole here as well. So therefore, number of moles of Fe is equal to 3.4 10 to the power minus 3. Right. Let us get the mass of Fe. Mass of Fe is equal to 3.4 10 to the power minus 3 moles multiplied by 56 grams per moles. Per mole, moles cancels out. Did you understand that? 3.4 10 to the power minus 3 multiplied by 56 is equal to 0.1904. 0.1904 grams. What is the next thing? Next thing that they ask is, they ask you to calculate the percentage of iron in the steel. So what is the percentage? Percentage is equal to 0.1904 grams in zero point 0.2 grams multiplied by 100%. Divide by 0.2 multiplied by 100% is equal to 95.2%. 95.2%. Are there any questions here? Anything that you didn't understand? All right, okay. Thank you for confirming the answer. Why did you use Fe plus 2 instead of FeSO4? SO4 2 minus doesn't react. That is why SO4 2 minus is in the plus 6 oxidation state, minus 2, plus 6 oxidation state. It can't undergo oxidation any further. It won't react any further, right? Right? What are spectate ions except potassium? There are so many spectate ions that will not react with the species. That is what you mean by spectate. Spectators don't participate in the match. I have mentioned this many times. Sodium is a spectate ion, calcium is a spectate ion. So many spectate ions can be there. See, it depends on the compound, whatever the compound that is there, and that compound uh, does not change the oxidation state. It doesn't react with potassium permanganate. They are the spectate ions that you consider. Right? Okay, right. You say that is question number 14. Question number 14. So that is okay. Question number 14. 15, 16, I haven't done the theory. That comes under iodometric titrations. I have discussed potassium permanganate based titrations. I have discussed potassium dichromate based titrations. These two we have discussed. So last thing to remaining is iodometric titration. After that, we will discuss the remaining ones. Right. Question number 18 also like that. 19 also like that. But under 20, I think we discussed this, right? We discussed question number 20 as far as I think. Yeah? Is it clear? Yeah. Then we will look at question number 21. I think we haven't discussed question number 21. Question number 21, okay? Right. Let us read that question. Ammonium iron 2 sulfate has the formula ammonium sulfate. This is ammonium sulfate. Ammonium sulfate. Iron 2 means Fe plus 2. FeSO4 dot NH2O. Now, if you look at the titration tier, like, those handouts that I have given you, asking you to paste it in the books, they are the reactions that you need to worry about. Nothing else. Those reactions I want you to look at. And I told you that these are oxidizing agents, potassium permanganate, potassium dichromate. So the lower oxidation states undergo oxidation, right? In an experiment to determine the value of N, so they want to get the value of N. This value, 8.492 grams. This entire sample is 8.492. Was dissolved and made to a solution of 250 milliliters. The first thing that you do is you make it to a 250 milliliter solution of the solution with sulfuric acid and distilled water. So it's acidic material. 25 milliliters was further acidified. You take from that 25 milliliters. And titrated against potassium permanganate. So you titrate it using KMnO4. Concentration is 0.015. Volume is 22.5 milliliters. Calculate the value of simple length. Calculate the value of simple length. That is what they ask. Now again, somebody asked me again, balance the equation, explain balancing equation. So here we are doing balancing equation again. Fe plus 2 MnO4 minus turns into what? Mn plus 2 and then what else? Fe plus 3. Right? Here plus 2 to plus 3, you have 1 electron. Plus 2 plus 3, 1 electron. Here the oxidation number is plus 7. Oxidation number is plus 2. Here you have 5 electrons. The gap is 5. In order to cancel out the electron, you have to multiply this by 5. So multiply this by 5, this by 5. Now you can see on the left hand side there are 4 oxygen atoms. So let us add 4 water. That means on the right hand side now you have 8 hydrogens. You have to balance it by adding 8H plus. Is it clear? Now that is the balance equation. Now I'm going to work on 25 milliliters. 25 milliliters. Then later I'm going to work on to 250 milliliters. Let's see how we can do that, right? So number of moles of Fe plus 2, number of moles of permanganate, MnO4 minus. Fe plus 2 is 5, permanganate is 1. What is the number of moles of Fe plus 2? Number of moles of Fe plus 2 is 5 times number of moles of permanganate. What is the number of moles of permanganate? 0.015 times 22.5, 10 to the power minus 3 moles. Uh, 5 times 0.015 times 22.5, 10 to the power minus 3. What did you get? 1.6875, 10 to the power minus 3. 6875, 10 to the power minus 3. Is it clear? So this is the number of moles of Fe plus 2 present. Now that was present in, may look at the laser pointer, that was present in 25 milliliters. That was present in a small volume. But the total amounts were, you have to calculate in 250 milliliters. So let us do that, right? So number of moles of Fe plus 2 in 250 milliliters. How much is that? Divide by 25 multiplied by 250. So that means 1.6875, 10 to the power minus 3 multiplied by 10, that means 10 to the power minus 2 moles. 1.6875, 10 to the power minus 2 moles in 250 milliliters. Right? So now you can see inside this is our compound. This is our compound. Inside this, you have Fe only one. Fe, there is only one. So that means total number of moles of this is also the same as Fe plus 2. So number of moles of the salt is equal to 1.6875, 10 to the power minus 2. Now you know the mass, so therefore you can calculate the molecular mass. So molecular mass is equal mass divided by number of moles. What is the mass that you have taken? 8.492. (1.6875), 10 to the power minus 2 moles. So you get the molecular mass as grams per moles. If there are any questions, you should ask. It's like, other today's like, it looks little different than the usual chat. I think I need to figure it out. 8.492 divided by 1.6875 10 to the power minus 2 is equal to 503. Molecular mass is 503. Right? 503.2 kelvin. Right? So this is the molecular mass. So we need to calculate N. Right? So let us look at that. Ammonium sulfate. What is the molecular mass of ammonium sulfate? Ferrous sulfate. What is the molecular mass of that? N water. Ammonium sulfate. 18 times 2 plus 32 plus 64. 132. Ferrous sulfate, 56 plus sulfur, 32, 64. 152. Plus 18 simple N. So what is the total amount? 132, 152 plus 132, 152. Here then 284. 284 plus 18N is equal to 503. Let us calculate N. 503 minus 284 divided by 18. 12.16 kelvin. What is the answer they have given? 12.16. So I think 12 kelvin. Which question? 21. 21, 12, yes. Question number 21. So you get N is equal to 12. Did you all understand that? What everybody understood that? Yeah, okay, right, good. Some of you have, right? You have got that answer, right? Clear? Is the conversation clear, Puta? Is the conversation clear? Takdala dand? Is the conversation clear? Are we getting stuck? Yeah, no problem. Okay, right, fine. Some people say that it is getting stuck and all that. Right, okay, good. Hari. Okay. Right, so did you understand that part? That is question number 21. Question number 21 is that, right? So gradually you have to become better at it. When you keep on working on this, you will be all right. Huh? Right. Right. So shall we look at the question number 22? Question number 22. See whether we can work it out. The sulfite of group 1 metal was oxidized by aqueous potassium dichromate under acidic conditions. Some group 1 metal, sulfide. So group 1 means the oxidation number is +1. Sulfite means MSO3 2 minus. So you need to exchange the valencies. Then only you can get the formula. M2SO3 is your compound, right? Under acidic conditions. So dichromate, you oxidize it using acidic conditions. 1.9 grams of the anhydrous metal sulfite was used. So this is 1.9 grams. Sulfite was made up to 250 milliliter solution. So this was made to 250 milliliter solution. Solution with acid and water. 20 milliliter portion of this solution, out of that you take 20 milliliters. 20 milliliter portion of this solution was titrated with 0.2 molar potassium dichromate. 0.2 molar dichromate, K2Cr2O7. Following burette readings were obtained. Right? So you can see the starting reading and the final reading, right? Can you see starting reading and the final reading? The first trial, like numbers first trial you start from 8.6 and you go to 26. Can you tell me the burette volume? Can you tell me the burette volume? Can you calculate and tell me what is the burette volume that you see? Hare? So slowly තමයි ඉතින්. මේ තමයි slowly. Right? What is the burette reading? What is the change in the burette reading? Can you calculate and tell me? So you start 26 is the final reading, 8.6 is the initial reading. What is the value that you get? Can you balance? Huh? 14 නෙවෙයිනේ පුතා. 17.4 subtract and give me 17.4 milliliters. First reading is 17.4. The next one is you start with 26 and then go to 42. What is the burette reading? What is the burette reading? Can you all tell me? Not the burette reading. What is the volume that is needed? Yes. What is the volume that is needed? 16 milliliters. 16 milliliters. Everybody okay? 16 milliliters. So you get 16 milliliters for the second one. Let us look at the third one. Right? Third one is you start with 1 and it goes to 17.6. What is the value that you get? 16.6 subtract and give the answer 16.6 milliliters. Then the next one is 17.6. It goes to 33.6. Can you tell me what is the value? 33.6 minus 17.6. What do you get? You get again, what is the answer? You again get 16 milliliters. Everybody understood that? 16 milliliters. Now, out of all these readings, there is one reading that we know that that is not right. What is that reading? Which reading is not right? What is the reading that you think is not right? Out of these 4 readings, there are 4 values. You can see the first trial reading is not right because it has a kind of a big difference. There's a big difference, right? That was a kind of a, now usually we said that it is a crude trial. So this reading is not very accurate. So now what you do is when you're taking the average, you take only the other 3 which are close to each other, right? These are the 3 readings that you take. So what is the average reading? Average reading is 16, 16, 16.6 divided by 3. What is that? 16.2 milliliters. Did you all understand that? Yeah. Everybody understood that? Yeah. What is the average? Did you get the average? Calculate and tell me whether the average is right. Out of these 3, average, you divide it by 3, 16.2. I hope all of you understood that. Right. Then it says, the questions they ask, what color change would be observed during the titration reaction? This is a dichromate titration. You add an indicator. What is the indicator that is being added? You have to add a redox indicator. What is the redox indicator that usually you add? We talked about this. And how to get the average? Three things. You add them together, divide by 3. Right? How do you get the average? Average you divide by 3. So what is the indicator that you know you add diphenylamine sulfonate. So you call that diphenylamine indicator. Diphenylamine indicator. You're taking the average. The 17.4 you remove other 3. Usually class average right? You divide by 3. Like, there are 3 readings. Right, okay. During the reaction, sulfite ion is oxidized and the dichromate ion is reduced to chromium 3. Give the ionic half reactions for both reactions. Hence show that 1 molar dichromate can oxidize 3 moles of sulfite ions. Right, okay. So you need to go with the half reactions. Now, sulfite ions, SO3 2 minus, I told you what is the rule for sulfur. Sulfur can jump to the next available oxidation state. This is at the moment plus 4. Plus 4 goes to plus 6. Sulfite goes to sulfate. Right? Let us balance it by adding 1 water molecule and 2H plus. 2H plus means 2 electrons. So there is a reaction that is taking place. Right. Chromate ions, dichromate ions Cr2O7 2 minus, what is it turning to? It turns into Cr plus 3. Balance current. 2 chromium, 2 chromium. 7H2O, 7 times 2, 14H plus. 14H plus minus 2, 12, 6 electrons. So now what you do is, in order to balance this, you have to multiply this by 3. And you get 3 water plus 3 sulfite ions, SO3 2 minus, 14H plus, dichromate, giving you 3 sulfate, SO4 2 minus, 6H plus, 2Cr plus 3, and then 7H2O. If you want, you can cancel some of these things out. Here, 7H2O, 3H2O, that will give you 4H2O. 6H plus, this is 8H plus. Right? So likewise, I think we should be able to do that. And it says, hence show that 1 molar dichromate ion oxidizes 3 moles of sulfite ions. So number of moles of dichromate to number of moles of sulfite. What is the answer? Dichromate is 1. Sulfite is 3. I hope everybody understood that. Why do you not add the 17.6 when taking the average? Because it is very off. 17.6 is really, really off. It should be close to each other. Otherwise, you can't take the average like that. Then you don't get the reading. And that is the first reading. Usually first reading is, it's a wrong reading. Because we are blindfoldedly looking at this gradually. What titer value would you use for the calculation? What is the titer value that we use for the calculation? Third one. What is the titer value that we use for the calculation? Which one are we going to use? So you use 16.2 milliliters. Is it clear? Otherwise, average would be very off. 16.2 plus 17.6 divide by 2. Go to 16.9 LNA. Right? That is like really off. Did you understand that? Is it clear, children? Everybody understood this? Any other questions out of that? So 16.2 milliliters is what we are going to use. Right. What is the next one? Use the data to, what is the color change? Diphenylamine indicator, what is the color change? What is the color change that you see in the diphenylamine indicator? Can you tell me? It is initially, I showed you the titration also the other day. ඉතින් ඒක මතක තියෙයි කියලා මං හිතනවා. I showed you how the color changes take place. What are the color changes? Yeah, so it gives you green to purple color, right? Color change is green to purple color. Green color, and it turns into purple color. Green to purple color. Everybody understood that? 16.2. Use the data to calculate the relative molecular mass of the metal sulfate and sulfite, identify the metal, right? So if you know the dichromate amount, if you know the you can calculate the sulfite amount. So number of moles of sulfite, number of moles of sulfite is equal to 3 times the number of moles of dichromate. What is that? 3 dichromate. What is the amount? You know the concentration 0.2 and 16.2. 0.2 is the concentration, moles per cubic decimeter. Volume is 16.2. 10 to the power minus 3 cubic decimeters. Is it clear? So this and this cancels out. So this is the number of moles of sulfite ions. 3 times 0.2 times 16.2 10 to the power minus 3. You get 9.72 10 to the power minus 3. Can you confirm that? This is the number of moles of sulfite ions. පොඩි ඒවා ටිකක් තියෙන්නේ. These calculations are very simple, right? උදා colorless to green නෙවෙයි. මේ colorless to green කියලා කියන්නේ මේ this is what you get. Chromium plus 3 is formed. 0.02 the තිබ්බේ concentration එක double check 0.02, yes, 0.02 0.02. So that means this is 4 10 to the power minus 4. 0.02. The colorless නෙවෙයිනේ. The chromium is green in color, chromium, and the purple color turns the indicator turns into purple color. It's not colorless, right? Endpoint titration at the endpoint. Endpoint color is green to purple. I have given you those colors, right? 9.72 10 to the power minus 4. Let me double check. 3 times 0.02 times 16.2 10 to the power minus 3. 9.72 10 to the power minus 4 is the number of moles that is present. Okay, right. Then that is in how many milliliters? They have taken 20 milliliters. Total volume is 250. So let us look at how much is that. So number of moles of sulfite in 250. Kiyada? 9.72 10 to the power minus 4. That was for 20 milliliters. What is the amount for 250 milliliters? 9.72 10 to the power minus 4 multiplied by 25 divided by 2. So that gives you 0.01215. Balanda. 0.01215 moles. So that is the number of moles in 250 milliliters. Three times 0.02 times 16.2 10 to the power minus 3. Yeah, 9.72. Right. So this gives you 0.1215 moles in 250 milliliters. Is it clear? So now you can calculate the molecular mass. Molecular mass is equal mass divided by the number of moles. What is the mass that you have taken? You have taken 1.90 grams. 1.90 grams. The number of moles present is 0.01215. moles. So you get 1.9 divided by 0.01215 is equal to your molecular mass is 156 grams per moles. This is your molecular mass. So then it says use the data, calculate the relative molecular mass of the metal sulfide. So relative molecular mass, no unit, 156. Identify the metal. What is the metal? Metal. So let us say metal atomic mass is X, sulfur is 32, oxygen is 1664. This is equal to 156. Here the X. What is the value that you get? 156 minus 32 plus 64. 60 කියලා atomic mass. මේක ඔක්කොම තියෙන්නේ වෙනස් උත්තරනේ. 60. What is 60? Look at what is 60. 60 එන්න බෑ නේද? Oxygen. Yes. Okay. Oxygen is 48, not 64. SO3, right? 48. එතකොට කීයද එන්නේ? 32 plus 48. 80. 156 minus 80. 76 එන්නේ. 76. What is 76 that you get? Yeah. 76. Sodium 23, potassium 39, rubidium. What is the atomic mass? Do you have a periodic table close by? I don't have a periodic table. But then this, do you have a periodic table? No. Rubidium is 85. Rubidium 85. Yes. I made a mistake here. So what is this? I wrote it here, but I didn't use it. This one. This one is, okay, we'll take that as well. So your compound is M2SO3. So 2X plus sulfur 32, oxygen is 48, is equal to 156. 2X is equal to, what is that? 156 minus 32 minus 48, 76. X is equal to 76 divided by 2, 38. එතකොට හරි නේද? Roughly equal to potassium. Your compound is K2SO3. Everybody understood that? Yeah, not X. It should be 2X. හරිද? No, it's 2 times. It's 2 times. I hope you got the idea there. Right? Everybody okay? Did you all understand that? Because it is K2SO3. It's not K2, M2SO3. There are 2. There should be 2 of them. That's why I made the mistake. So this is wrong, huh? M2SO4, right? Yeah, potassium is 39, yes. So roughly that is the closest one you can get, right? Potassium is 39. Everybody understood that? Any questions here? So question number 22 is all right, I hope. Shall we go to question number 23? 22, that was. Question number 22. All ready to work on that. What do you say? Question number 23. Any questions from the earlier one? Any questions from the earlier one? Anything that you couldn't understand? Right. Then let us go to question number 22. Right. Let's read the question. Potassium manganate 7, that means potassium permanganate, is an effective oxidizing agent when mixed with dilute sulfuric acid. So you understand that it's an effective oxidizing agent. When mixed with dilute sulfuric acid, it is able to oxidize iron 2 to iron 3 ions. Solutions containing Fe plus 2 can be titrated against potassium manganate 7 solution. This is something that we already know. This titration forms the basis of analytical technique for the estimation of iron in substances such as flour. Right. 1 gram of flour. So you take 1 gram of flour. So this is 1 gram. It contains Fe. Was vigorously shaken with dilute sulfuric acid and the volume of the solution was made up to 100 milliliters. Solution was made up to 100 milliliters. 10 milliliter portion of the solution. So out of that you take 10 milliliters. 10 milliliter portion of the solution was titrated with 5 10 to the power minus 6. 5 10 to the power minus 6 permanganate. An average of titra 11 milliliters was required. So you need 11 milliliters. Then they say copy and complete the balance equation for the titration reaction. So they have given permanganate MnO4 minus is given, and then Fe plus 2 is given, and then they have given H plus, gives you Mn plus 2. Don't sleep, huh? Right? Fe plus 3. What is the other one? H2O. Haha. You get this reaction. Can you balance it? How do you balance it? Plus 2 here, plus 3 here. So you need only 1 electron. This is plus 7 here. This is plus 2 here. You need 5 electrons. Multiply this by 5. 5. This is also 5. 4H2O. 4 times 2, 8H plus. So you get the balance equation. I hope everybody got that. Clear? Then it says calculate the number of moles of permanganate used in the each titration. So number of moles of permanganate MnO4 minus is equal to concentration times volume 5 10 to the power minus 6 multiplied by 11 11 10 to the power minus 3 moles. Again, how much? 55 10 to the power minus 9 10 to the power minus 6 ned? Right. 55 10 to the power minus 9, that means 5.5 10 to the power minus 8 moles. Is it clear? Cool. Well, can Unahari say something here? Did you get those numbers? Yeah. Right. Okay. Right. Good. Yeah. Okay. Fine. So that is okay. Na? Okay. 55 10 to the power minus 8. So here the solution, you have taken only 10 milliliters. That was for the titration 10 milliliters. Total amount is in 100 milliliters. That means 10 times the value. So number of moles of Fe plus 2 to number of moles of permanganate. Fe plus 2 is 5, permanganate is 1. So what is the number of moles of Fe plus 2? Number of moles of Fe plus 2 is 5 times 5.5 10 to the power minus 8 moles. That means 5 times 5, 5.5, 5.5 times 5 is equal to 27.5. 2.75 10 to the power minus 7 moles Fe plus 2. That was present in 10 milliliters. Let us look at the number of moles of Fe plus 2 in 250 milliliters. In 250, not 250, 100 milliliters. 100 milliliters. So 2.75 10 to the power minus 6. This is the number of moles present in this amount. Did you understand that? Somebody asked me, why do you take 11 milliliters instead of 10 milliliters? Within 11 milliliters is the volume of potassium permanganate. This is the volume of the titration. We take 10 milliliters to the volumetric flask, and when you titrate, burette reading is 11. So 10 aragena hariyanne, you have to take the 11. You can't take 11 or 10 because that's the burette reading is 11. Right? 2.75 10 to the power minus 6. Haritha, did you understand that? 2.75 10 to the power minus 6 is the number of moles of Fe plus 2 in 100 milliliters. Right. So what do they ask? Calculate the number of moles of iron in 1 gram of flour. Right. That's okay. Now this is the number of moles of flour. Flour must contain 1.65 milligrams of iron per 100 grams of flour by law. By carrying out the appropriate further calculation, decide if this flour contains sufficient iron to fulfill the legal requirement. So 2.75 10 to the power minus 6 multiplied by milligrams, 56 times 10 to the power 3 milligrams in 1 gram. 1 gram of flour contains this amount. What is that amount? 2.75 10 to the power minus 6 multiplied by 56 10 to the power 3. 56 times 1 10 to the power 3 milligrams. 0.154 milligrams. 154 milligrams in 1 gram. So in 100 grams, how much? You can have 15.4 milligrams. Multiply by 100. It must contain 1.65. This is 15.5, 15.4. So it is sufficient to fulfill the requirement. Right? Sufficient to fulfill the requirement. sufficient to fulfill the requirement. Harideka, did you understand that? Right, 1.54 milligrams, I think in 1 gram, 100 grams, 15.4. 100 grams. What did you get? So did you all get those answers? Shape the everybody. Is it clear? All right, okay. Did you get those answers, children? Or you haven't done it? Right. So that was question number 23. Right. Question number 23 is also done. Right. Let's see whether we have. Okay. Shall we do one more question? Shall we do one? I think we did discuss this. The question number 24, did we discuss that? Question number 24. Question number 24. We have done this before, Hari. Right, okay. In a hurry. 24 Hari. 25, we haven't done it yet. Right? The theory, we haven't done it yet. Question number 26. Shall we do question number 26? We'll do it next day. Again. Question number 26. Do it now. Yes, yes, can do it now. Now hurry again. We'll do. Right. Okay. Let us do it. Right. Let us do it. Right. Right. Okay. So right. Okay. Lot of people saying let us do it. Right. Okay. Now, in order to analyze an impure sample of vanadium oxide, vanadium oxide means vanadium 5 oxide. Vanadium 5 oxide means V2O5. 0.2 gram sample was treated with sulfuric acid. So they treat with sulfuric acid. 0.2 gram sample was treated with sulfuric acid. And excess of sodium sulfide. And then you add sodium sulfide, Na2SO3, they have added. A blue solution containing vanadium, this compound was formed. It gives you VO2 plus sambralu. VO2 plus. This solution required 20 milliliters of 0.02 molar potassium permanganate. Vanadium back to this one. The equations of the reactions which occurred were, now they have given all the equations. I will take a photograph of this and we will add this. We don't have to write it again. So we will take a small photograph here and then we'll put it there. Right? So where is our photograph? Here you have the photograph. So we will cut this off. This reaction on the cut. This is also, this part also we cut it off. Right? And then what you do is, the reactions are there. So it's easy. So you can see in this reaction, this is vanadium pentoxide. This is permanganate. The amount of permanganate we know. Right? Let us look at the number of moles of permanganate. What is that? 0.02 times 20, 10 to the power minus 3 moles. 0.02 is there, 20 is there, 10 to the power minus 3. Let us look at that. 0.02 times 20, 10 to the power minus 3 is equal to 4, 10 to the power minus 4. Potassium permanganate. 4, 10 to the power minus 4. Hari. If you know, if you know the number of moles of potassium permanganate, I think we should be able to calculate the number of moles of VO2 plus using that equation, right? So number of moles of VO2 plus to number of moles of permanganate, MnO4 minus, is equal to 5 to 1. So number of moles of VO2 plus is equal to 4 10 to the power minus 4 multiplied by 5. That means 20 10 to the power minus 4. That means 2 10 to the power minus 3. බලන්න පුතා හරිද කියලා? Did you understand that part? Is it clear? Everybody understood that? Using that equation. That is the equation that we use. And I made this one, this highlighted equation, this part. Now, where did you get the VO2 plus? From the second reaction. So I will highlight that using this purple color. You get it from the second reaction, right? And then I think we should be able to calculate VO2 plus, right? So number of moles, we are looking at the second reaction. Number of moles of VO2 plus to number of moles of VO2 plus is equal to මේකත් දෙකයි නම් මේකත් දෙකයි. Check whether you understood that. මොනවා හරි තේරෙන්නේ නැත්නම් you need to ask. Right? Look at this. Look at this one here. There's 2 here. මෙතන දෙකයි, මෙතනත් දෙකයි. VO2 plus VO2 plus. So 2 is to 2. That means 1 is to 1. Right? So this means number of VO2 plus is equal to 2 10 to the power minus 3. This is equal to 2 10 to the power minus 3. This one is 2 10 to the power minus 3. We have calculated it earlier. Band Haridike. Now we understand. We can look at the next reaction. What is the next reaction? Next reaction is this reaction. This reaction. The first reaction. Look at that. It says VO2 plus and V2O4. Number of moles of V2O5 to number of moles of VO2 plus. Can you tell me the stoichiometry? Tagdal again, Brand. Stoichiometry. What is the stoichiometry? By considering the first reaction. Can you all tell me the stoichiometry, children? What is the stoichiometry based on the first reaction? V2O5 and VO2 plus. What is the stoichiometry? V2O5 and VO2 plus. Stoichiometry. Tagdal again. What is the stoichiometry that you see? They're very difficult to get to your chats. I don't know why that is. This is. Yeah, okay, good. Correct answers. Yeah, very good. Yeah, so what will happen? V2O5 and VO2 plus. V2O5 is 1 here. Look at this one. Here it is 2. V2O5 1 and VO2 plus is 2. So number of moles of V2O5 is equal to VO2 plus is 2 10 to the power minus 3 divided by 2, 1 10 to the power minus 3. What do they ask? Right? Using this data, calculate the percentage by mass of vanadium in the sample of vanadium oxide. So, what is the vanadium in the sample? Mass of vanadium is equal to 1 10 to the power minus 3. There are two vanadiums. Atomic mass is 51 grams. Well, 1 10 to the power minus 3 multiplied by 2. They ask you to calculate the vanadium. So you have to multiply it by 2 times 51. No, 0.102 kilo, no, 0.102 grams. So what is the mass percentage? What is the mass percentage? Percentage mass is equal 0.102 divided by total weight is 0.2 grams. Multiplied by 100%. What is that? Divide by 0.2 multiplied by 100% is equal to 51%. Is it clear? Everybody understood this? Question number 26. Children? I hope all of you got the idea there. Right, Hari. Yes. Then we are okay na? Like tutorial number 6, like we have some more to discuss, 27 28, and there are some other iodometric calculations. We'll do this like hopefully like next week. Now Saturday we don't have classes, na? So we will work out. Do we have classes this week? Right. Shall we go to the gases question? Now, what are the like any questions that you tried and you couldn't do, you couldn't get the answer, something like that? Any troubling questions? We can discuss them. Otherwise, I think I might have given you some questions to work on. Api කොහොමද කරන්නේ? Which question are we going to start first? Can බලන්න suggest give me your suggestions. Right? Give me your suggestions, will you? Shouldn't we take the molecular mass of vanadium? No, they asked you vanadium. Vanadium, not the vanadium pentoxide. They asked you to get the vanadium. Right? Vanadium, not from the vanadium pentoxide. Right? Clear? Okay. So what was the questions I said we will start discussing? Just to check. I can't remember now. What are the questions that we said we'll do? අපි කිව්වා 2026 එකේ අපි කිව්වා we said page number 5 and 6, page number 5, starting from question number 16. Question number 16. A gaseous mixture. Let's look at page number 5, question number 16. A gaseous mixture contains 40% ammonia, NH3 40%. Ammonia 25% hydrogen, 25%. 35% nitrogen, 35%. Volume 1.5 10 to the power 5 pascals. 1.5 10 to the power 5 pascals is the pressure inside the rigid container. Calculate the partial pressures of this. According to the Dalton partial pressure law, partial pressure of any species is equal to molar fraction of that species times the total pressure. Molar fraction is proportional to the volume. According to the Avogadro's theory, number of moles is proportional to the volume. So therefore, molar fraction is proportional to the volume fraction. So if you look at partial pressure of ammonia, molar fraction is 40 divided by 100. Because it says 40% out of 140 volume. And then molar fraction is also the same, 1.5 10 to the power 5 pascals. So what is that? 0, 0 cancels out. 1.5 is 6 10 to the power 4 pascals. If there are any part that you didn't understand, you need to ask that question. Hydrogen 25 divided by 100. Again, the percentage is 25 divided by 100. 25%. So fraction is 25 divided by 100. Multiplied by 1.5, 10 to the power 5 pascals. So what is the answer? You get 25 times 1.5 10 to the power 5 divided by 100. 3.75 10 to the power 1, 2, 3, 4. 4 pascals. And then what is the next one? Partial pressure on nitrogen. Partial pressure on nitrogen is equal to 35 divided by 100 times 1.5 10 to the power 5 pascals. So it gives you 3.5 times 10 to the power 5 times 1.5 divided by 100 is equal to 5.25 10 to the power 4 වගේ එකක්. 5.25 10 to the power 4 pascals. ඊට පස්සේ if ammonia is absorbed using P2O5, calculate the new partial pressures. Give reason for your answer, right? If ammonia is removed, then ammonia is not there. What will happen? Total pressure drops because ammonia is taken, ammonia is absorbed. So in the total pressure drops. So what will happen is total pressure decreases. Total pressure decreases. What happened to the molar fraction? Molar fraction is number of moles divided by number of moles of A divided by total number of moles. Total number of moles decreases, therefore molar fraction increases. Molar fraction increases. Now, the partial pressure, no change. Partial pressure has no change. Pressure not changed. Why is that? Because drop in the total pressure is cancelled out by the increase in the molar fraction. So there is no change in the partial pressure. Did you understand that? There is no change in the partial pressure at all. Why did you say that the percentages are molar percentage? The question says percentages are given by the volume. Like, you have a Avogadro's theory at constant temperature, constant pressure, volume is proportional to number of moles. So if the volume is high, number of moles are high. Volume is low, number of moles are low. Molar fraction is equal to volume fraction. Did you understand that? Can we take the total volume as 100? එහෙම ගන්න ඕනේ නැහැ. එහෙම ගන්න එපා. එහෙම ගන්න එපා. එහෙම කියලා නෑනේ. Right? Volume මෙහෙමනේ තියෙන්නේ. Now like, let us go through this a little better. තව ටිකක් අපි මේක detail එකක් බලන්න. So let us say you have a number of moles of nitrogen. The number of moles of nitrogen is proportional to the volume of nitrogen, K times volume of nitrogen. Number of moles of ammonia is equal to K times volume of ammonia. Number of moles of hydrogen is equal to K times volume of hydrogen. What is this? This is the Avogadro's law. Number of moles is proportional to volume. ඔහොම එකක් අපි දුන්නේ. මතකද? So what is the molar fraction of nitrogen? What is the molar fraction of nitrogen? Molar fraction of nitrogen means number of moles of nitrogen divided by the number of moles of nitrogen plus number of moles of hydrogen plus number of moles of ammonia. ඕක තමයි molar fraction of nitrogen is that. Molar fraction means that. Number of moles divided by total number of moles. But you know number of moles of nitrogen is equal to K times volume of nitrogen. May using this equation. මේකත් එහෙමයි. K times volume of nitrogen plus K times volume of ammonia plus K times volume of hydrogen. You think K is common? It will cancel out. Common may cancel out. So that is equal to volume of nitrogen divided by volume of nitrogen plus volume of ammonia plus volume of hydrogen is equal to molar fraction. Molar fraction of nitrogen is equal to volume fraction. Okay, like you can directly use that. Did you understand that? Is it clear? Can you prove that the pressure doesn't change? Pressure changes. Total pressure changes. But the partial pressure doesn't change. Did you understand that? Please tell me, like whether otherwise I get stuck here. I'm just waiting. That is the least that you can do. Tell me whether you understood it or otherwise you have to ask the question. Right? Is it clear? So molar fraction is equal to volume fraction always. Right. It was said, do you want me to prove that the partial pressure doesn't change? We can try to prove it and see. Partial pressure doesn't change. Right? Partial pressure doesn't change. Okay, right. So let us look at this one. Rigid container. This is a rigid container. So you have A, B, C gases. You might have to patiently watch this. A, B, C gases. Simple A, simple B, simple C, number of moles are there. These are the number of moles. Did you understand that? Right. Let us say partial, the pressure is capital P. Can you tell me what is the partial pressure of A? Partial pressure of A is equal to molar fraction A divided by A plus B plus C times total pressure P. Okay, agree though? Do you agree with that? Do you agree with that? Do you agree with that? That's okay, ne? Everybody understood that? Right, okay. So that is your partial pressure, right? Then what you do is, let us say you are going to remove some gas. Api ayin karamu, C ayin karamu, right? But since it is a rigid container, volume doesn't change. Volume is V, temperature is T. Here also volume is V, temperature is T. Total pressure changes. A, B vitarai tiyenne දැන්. You have simple A moles, simple B moles. Pressure changes to P2. Right? P2. So now what is the partial pressure? Partial pressure of A is equal A divided by A plus B times P2. Did you understand that? Now, moles divided by the total number of moles times pressure P2 is the partial pressure of A. Do you agree with that? Yeah, right, okay. A divided by A plus B times P2. But then from this you can't say whether this has changed. So what I'm going to do is I'm going to apply PVNRT to the first one, PVNRT to the second one. So pressure volume is equal to nRT, A plus B plus C times RT, equation 1. Nah? Second one, P2V is equal to A plus B times RT, equation 2. So 2 divided by 1 and the volume cancels out. P2 divided by P is equal to A plus B divided by A plus B plus C. Right? What is P2? Now partial pressure, not the partial pressure, total pressure is equal to A plus B plus divided by A plus B plus C times P. Now, this is your pressure 2, pressure in the second container. Did you understand that? Is it clear? Everybody understood this? Yeah. Right. Okay. Now calculate the pressure 2. What is the partial pressure of A? Partial pressure of A is equal, me make a A divided by A plus B. P2, what is P2? P2 කියලා කියන්නේ A plus B divided by A plus B plus C times P. ඉතින් ඔයාලට AB cancels out. එතකොට what is the partial pressure? A divided by A plus B plus C times P. තමයි partial pressure of A. So you can see that it has not changed. Earlier also you had the same value. Now also you have the same value. You can change A, B, C, whatever the way you want to change. You can put any number there. But then still the partial pressure doesn't change. Is it clear? Did you understand that? Children? Right. Okay. Like, when you remove some kind of a gas, the partial pressure should not change. Right? It never changes. As long as the temperature and the volume are the same. If the temperature and the volume is different, then we should be able to, right? Okay? Right. So you don't have to prove it, but then you have to understand it. Understand it. Right. Question number 16 is that. 17, I think we discussed that. But question number 18. Did you get the answer? Question number 18. Right. Question number 18. The flask contains 200 cubic centimeters. 200 cubic centimeters. And 200 millimeters mercury. And the other flask contains 300 centimeters, cubic centimeters, nitrogen and 100 millimeters mercury. Two flasks are connected. Deka connect karalu. Titik gala. Right? Oxygen make it, and this one is nitrogen. So you connect them together. Right? Calculate the total pressure of the gases mixture, assuming that the gases do not react with each other and the temperature remains constant. What you do is, right, remaining things are there, right? So we use P1 V1 is equal to P2 V2. Like, don't apply PV and RT, right? So you have 200 milliliters, 200 millimeters mercury. Pressure 2, what is the total volume? Total volume is 500 milliliters. So milliliters, this double zeros cancels out. 5 times, this is 40. 40 times 2, 80. P2 is equal to 80 millimeters mercury. So when you add this volume expands and the 200 millimeter mercury change into 80 millimeters mercury. Right? Nitrogen also, let us apply this equation. P1 V1 is equal to P2 V2. Pressure 1, 100 millimeters mercury, 300 milliliters. What is the pressure when the volume is 300, 200, 500 milliliters? So this and this cancels out. Double zeros cancels out. 5 times 20. 20 times 3, P2 is equal to 60 vendati. So what is the total pressure? P total is equal 80 plus 60, 140 millimeters mercury. Yes. Everybody understood that? Question number 18 it was. And question number 19 and 20 we will do and we will stop for today. Tomorrow is a school day also. Right. Don't we need to convert millimeters mercury to Pascal here? Because it will cancel out. Right? Unless if it doesn't cancel out, then you have to convert and do it. Make it cancel or not. If you multiply it by 760, divide by 760, multiplied by 110 to the power 5, you are going to do it on both sides. And it will cancel out. Right? Question number 19. Balan. Volume of 0.71 gram of an ideal gas, right? 0.71 grams of an ideal gas at 227 degrees Celsius temperature, 0.5 atm pressure is 0.821 liters. Calculate the relative molecular mass of the gas. PV is equal to nRT. Just to remind you, I'll derive it. PV is equal to nRT. PV is equal to simple M divided by capital M RT. What is capital M? Capital M is equal to simple M RT divided by PV. No, hurry. Right. So now let us calculate that mass is 0.71 gram. R is equal to 8.314. What is that? Joules per moles per Kelvin. What is the temperature? 227, 273, 500 Kelvin. Pressure 0.5. 0.5 times we use an approximate value. 1 10 to the power 5 pascals. Volume is equal to 0.821 10 to the power minus 3 cubic meters. What is the answer? Well, 0.71 times 8.314 times 500 divide by 0.5 times 110 to the power 5 times 0.821 10 to the power minus 3 is equal to 71.89. Answer is 65.28. Let me double check that whether I have made any mistakes. Grams per moles, right? 0.71. Okay. 0.71 times 8.314 times 500 divide by 0.5 times 110 to the power 5 times 0.821. 821 10 to the power minus 3. Yeah, 71.89 is what I got. What is your answer? Yeah, ඒක තමයි. ඒකේ මං හිතන්නේ answer is wrong, right? Yeah, 71.89. Yeah, somewhere there. හරිද? Right. So all of you got that answer. So this maybe answer is wrong. Ne? 71.89. Okay. Right. Did you do the next one also? Question part B. Let us do that as well. Calculate the final pressure of the gas at 20 degrees Celsius, 0.8 atm, when the temperature is increased up to 200 degrees inside a sealed container. Right? Final pressure, point. So there is this gas that is there. Temperature is 20 degrees, 293 Kelvin. And the pressure is 0.8 atm. 0.8 atm. Now what you do is you change the temperature to 200 degrees Celsius. 200 degrees Celsius means 473 Kelvin. What is the pressure? P2. Hurry. So this is how you do it. Let us say P1 V1 divided by T1. P2 V2 divided by T2. Pressure 0.8 atm. Volume V1. Temperature 293 Kelvin. Pressure 2, P2, volume V1. Volume is sealed container and nothing happened to the volume. V1 divided by temperature 473 Kelvin. So V1 and V1 cancels out. P2 is equal to 0.8 times 473 divided by 293 atm. If you want to convert this into Pascal, you multiply it by 10 to the power 5. හරි අපි නිකම් බලමු ඉස්සල්ලාම what is the answer? 0.8 times 473 divided by 293. What is the answer? 1.291 කියලා එනවා. 292. Oh yeah. 1.2914 කියලා එන්නේ 1 atm. Pascals 1.291 10 to the power 5 pascals. හරි නේද? හරි. ඒකත් හරිනේ. එතකොට question number 19 is okay. Question number 20 කරනවාද? Do you want to do that or next week ද? මොකද කියන්නේ? In P1 V1 and P2 V2 equation, do we want to keep the volume unit in cubic decimeters or ඒකට cubic there's no need of a proper volume. You can use any volume and then finally you get the final answer in that unit. එච්චරයි. You get the unit value in that unit. Yeah, okay. Right, fine. Shall we do the question number 20 also? Question number 20, first part. At temperature 10 degrees Pascal, 10 to the power 5 Pascal pressure, density is this. Calculate the density of air at 25 temperature and 3.5 pressure. Right. So, PV is equal to nRT. Simple M divided by capital M RT. Right. So, P capital M is equal to DRT. Did you understand that? So, you can say from the first one, you can calculate the molecular mass, right? DRT over pressure. Density of this gas is this much. ඊට පස්සේ, yeah. And then this is the density. අපි කියමු මෙහෙම. Density 1 R T1 divided by pressure P1. Right? From the second one also, molecular mass is equal density 2 R T2 pressure P2. This is the equation 1. This is the equation 2. Two different conditions, two different densities, but the molecular mass doesn't change. Molecular mass of a compound or a sample is always the same. So that means 1 and 2 are the same. Density 1 or T1 divided by P1 is equal to D2 or T2 divided by P2. R and R cancels out. What do they ask? They ask you to calculate the density of air at 25 degrees Celsius. Density 1 is given, na? 1.247 unit එකක් දාන්න. Kilograms per cubic meter. Temperature 10 degrees. 10 means 283 Kelvin. Pressure. What pressure? 110 to the power 5 Pascal pressure. This is equal to density 2. What is the temperature? 25 degrees Celsius. That means 298 Kelvin. Pressure 3.5 10 to the power 5 pascals. Right. So let us cancel some of these things out. Pascal, Pascal, this and this cancels out. Yeah. So D2 කියන්නේ මොකක්ද? 1.247 times 283 times 3.5 divide by 1, 298 kilograms per cubic meter. Check the answer. What is the answer? 1.247 multiplied by 283 multiplied by 3.5 divided by 298. 4.144 කියලා එනවා. 1448 එන 145. 4.145 kilograms per cubic meter. Shape ne එක නේද? Next one, I think you can do it. It's a same kind of calculation, right? You try that out. Same calculation. Part 2. You can try that out. Answer is also given, so you can try it on your own. Right, we'll look at question number 21 from 21 onwards next week. Right. Enang api will stop it at that point today. මොකද කියන්නේ? Yes. Everybody put in the band. Right? How do you obtain P1 in 16th question? P1 කියන්නේ මොකක්ද පුතා? What is P1? What is P1, Daru? Right? හරි. එතකොට how about the marks? තාම paper එක mark කරලා ඉවර නෑ. I am not a miracle worker. ඉතින් අපි මෙයා කරමු, right? Pressure before connecting. Pressure before connecting in question number 16. කෝකද පුතා question number 16? 16 is they have given 10 to the power 5 kilo inside the container. This part is given 1.5 10 to the power 5. It is given pressure inside the container in a rigid container, right? It's given, right? I started marking. Arida Balamo. I'll give the question. Arida, right? Okay. Right. Anything else? Any other questions? So no, anything else? Right, Hari. එතනින් අපි we will stop at this point, right? And then next week, that is now Saturday. කවද්ද Saturday there are no classes නේ. But next week on Thursday we will still have the Chemeve. එතකොට ඒකේ we will look at the question number 27, 28 in the chemical calculation tutorial, and we will focus more on gases so that we can finish that, like, major part out as well. හරිද? So that is the plan for the next time, right? Okay. හරි පුතා, right. um, good night Daru, right? Okay, right. Okay, bye.